So today I'll be giving you very basics trig identities, and in the next video I think we'll be talking about sine waves. I think David will make that video, and so now I'll just be deriving identities. So the first, let's just go over the 6 trigonometric values real quick. So sine is equal to 1 over cosecant, which is equal to 1 opposite over hypotenuse. Cosine is equal to 1 over secant, which is equal to adjacent over hypotenuse, and tangent is equal to 1 over cotangent, which is equal to opposite over adjacent. And you can memorize sine, cosine, and tan using so, ka, toa. And you're just going to have to memorize reciprocals. So quick review of the 6 trigonometric values. Now let's talk about it's good to know that tangent of x is the same thing as sine of x over cosine of x. This is true because we said that sine of x is the same thing as opposite over hypotenuse of x, and we can say that cosine of x is the same thing as adjacent over hypotenuse of x. If we rewrite it, we get, well, opposite over hypotenuse times hypotenuse over adjacent, and then we cancel this out, and this gets opposite over adjacent, so it's tan of x. So that's why it works. And then it's good to know that, well, if the tan of x equals the sine of x over cosine of x, then the reciprocal cotangent will equal the cosine of x over the sine of x. So yes, that's good. Now let's talk about the first very important identity you should know, and that is sine squared of x plus cosine squared of x is equal to 1. To prove this, let's construct a triangle. Let's call this A, B, and C, and let's call this angle x. Well, we know sine of x is the same thing as A over C, and we know cosine of x is the same thing as B over C. And so now we have to square them and then add them up. And if we do that, we get A squared plus B squared over C squared. By the Pythagoras theorem, we know that A squared plus B squared is the same thing as C squared. So we can substitute this in and get C squared over C squared, which cancels out to 1. So that's why this identity is true. And so now we're going to derive 2 more identities just using this identity. So what happens if we divide the whole equation by sine? If we do that, we're going to essentially just have this. Hold up, let me write it. So dividing the whole equation by sine squared of x, not sine squared of x. If we divide the whole equation by sine squared of x, we're going to get, well, sine squared of x over sine squared of x cancels out to 1. Cosine, we know that cosine over sine is the same thing as cotangent, but since there's a square, we write it as cotangent squared of x. And then we know 1 over sine squared of x is the same thing as cosecant squared of x. So this is another identity that is derived. Good to know. And you can manipulate this equation as well. Okay, so let's talk about what happens if we divide everything by cosine squared of x. Then we're going to get sine, let me just write it actually. So we're going to get this cosine squared of x over cosine. So if we divide the whole equation by cosine squared of x, we're going to get, well, we know that sine over cosine is the same thing as tangent, but since there's a square, we write a power of 2, and then the 2 should actually be before the x. And then cosine squared of x over cosine squared of x is the same thing as 1 because it cancels out to 1. And then 1 over cosine squared of x is the same thing as secant squared of x. So these identities are derived now. And so those 2 identities are important to know. Now I'll be talking about complement identities. We'll also be doing videos where we actually apply these identities and solve for pretty hard problems using the fundamentals of these identities. So complement identities, one complement identity you should know is that sine is equal to the cosine of 90 minus x. 90 also equals pi over 2 in radians, because if we wanted to convert it, we can just multiply it by pi over 180, and then we could simply just cancel out the degrees and write it as 90 pi over 180, or pi over 2. So yeah. So note that it can also be pi over 2 in radians. But how do we prove that why this identity is true? Well, let's just construct a triangle. And so let's call this x, and let's call this 90 because we're working with a trig. And we know by the triangle sum theorem, all the angles add up to 180, so this angle should be 90 minus x. And so if we take the sine of x, we get, let's call this actually length a, b, c. If you take the sine of x, we get a over c, and if we take the cosine of 90 minus x, we also get a over c. Alright, and so that's why it's proven, because we've just constructed a triangle. And the other ones you can, I'm going to name you two other, complement identities that you can derive using a triangle. So you can also derive these by using a triangle. So secant of x, or just to, so cosecant of x, it doesn't really matter, I just said cosecant of x is equal to secant of 90 minus x, and these identities are vice versa, so I could say sine of 90 minus x is equal to cosine of x. And then cotangent of x is the same thing as tangent of 90 minus x. And these can all be proven by simply just constructing a triangle. Now we've talked about those identities. Now let's talk about let's talk about quadrants. Now quadrants are good. So the reason why quadrants are important, because we need to know what quadrant are the sine and cosine, or all the trigonometric values positive or negative in. So there's a quick mnemonic you can do. You can say all students take calculus. And so all represents all, A represents all, S represents sine, and T represents tangent, and C represents cosine. And so this essentially tells you that for A, it tells you that all trigonometric values will be positive, and then and then for S, it says that sine plus its reciprocal, cosecant, will be positive, and the rest of the trigonometric identities will be negative in quadrant 2. So this is quadrant 2 and 1, quadrant 3, and quadrant 4, and then T, or tangent, tells you that tangent and its reciprocal, cotangent, will be positive in quadrant 3, and the rest will be negative. And then cosine, quadrant 4, tells you that cosine will be positive in quadrant 4, and the rest will be negative in quadrant 4. And so, yeah, just good thing to know, because we'll actually start applying these fundamentals to questions. Also, it's good to know negative odd identities. So if you had sine of negative x, this is the same thing as negative sine of x. And if you had cosine of negative x, this is important to know, it's just the same thing as cosine of x. And if you had tan of negative x, it's just the same thing as tan minus tan of x. So those are good things to know. And then let's cover sum to angle to different identities. Now, sine of x plus y is the same thing as sine of x times cosine of y plus cosine of x times sine of y. And then if we had if it was minus, or the difference identity, we simply just change the sign. Okay, so look at that for a bit. Okay, and then this is used to like calculate, for example, if you had sine of 75, we could break it down into sine of 30 plus 45, because we definitely know those angles from special right triangles. But don't worry, we'll have a problem video where we solve problems using these fundamentals. This video is just getting the basics out there and the formulas, identities you should know. And then if you had cosine of x plus y, this is actually different. It equals cosine of x times cosine of y minus, this is very important, the sign is not analogous to the identity, minus sine of x times sine of y. And then if it was minus, or like if it was a difference identity, you simply just change the sign. So that's very important to know. And then let's talk about tangent. We said tangent was sine over cosine, but there's also another way to write it. We can say tangent of x plus y is the same thing as the tangent of x plus the tangent of y over 1 minus the product of these two. And if it was a difference identity, we simply just change the sign. No, sorry. If it was a difference identity, we simply change the sign. So that's a good thing to know. Now let's talk about oh, by the way, you could, sorry, I went a little bit too fast. Let me actually go back to that. Oh, my bad. Let's actually go back to this. Sorry. Alright, I was trying to go back to that part. Alright, okay, yeah, that's good. So, sorry, I went a little bit too fast. Just look at that for a while, and yeah. So, because it's pretty hard, it's not that hard to memorize these identities, you just need a lot of application to problems. So, yeah. Alright, now let's talk about double identities, or double and half identities. Now, let's talk about sine of 2 theta. So, let's talk about sine of 2 theta. Sine of 2 theta is the same thing as 2 sine of theta times cosine of theta. And the reason why this is true, well, we know that sine of 2 theta is the same thing as sine of theta plus theta. Using our sum identity, we can say that this is the same thing as sine of theta times cosine of theta plus cosine of theta times sine of theta. And then if we group it, we get 2 sine theta times cosine of theta equals sine 2 theta. And then cosine of 2 theta is the same thing as what's it called? It's the same thing as cosine squared of theta minus sine squared of theta. And this can be derived by simply using the sum identity. Okay, so now okay. Let's talk about tangent of theta. I'm gonna need some room here. Or tangent, never mind. Tangent of theta is the same thing as 2 tangent of theta minus 1 over 1 minus tan squared. No, tan of 2 theta, not tangent of 2 theta. Tan of 2 theta is the same thing as 1 minus tan squared of theta, and it can be derived using the sum identity. Alright, so let's move on to half identities. So, good thing to know, that sine of theta over 2 is the same thing as sine, it's the same thing as plus or minus root 1 minus cosine of theta over 2, and then cosine of theta, I'll do it for in another color, is the same thing as plus or minus 1 plus cosine of theta over 2. So these look very similar. You just need to know the sign. Also, the plus or minus, it depends on what quadrant it is. And then tan of 2 theta, tan of theta over 2, I mean, is the same thing as 1 minus cosine of theta over 1 plus cosine of theta. So, yes, so essentially, and we'll cover sum to product to sum in a later video because that one is a little bit more advanced. And so those are the basic trigonometric identities that we covered. And we'll cover sum to product to sum in a later video. But thank you for watching. See you all next time.